voltage will remain same as the previous question. So, to allow double the current than the previous case, what should be the change that we can think about in area of cross section provided length is doubled? A2, here also you think in the previous case it happened that we came to the conclusion in the previous part that if the length is doubled, then area of cross section will also need to double provided to allow same current. But this time the current value will be double. So, previous part was V is equal to IR and final part is something V is equal to 2I into R dash. Current now in the second case, after changing the length as well as the area of cross section, the observation says that now the conductor will allow double current flowing through it. So, that means the new current will be 2I, potential difference remains same. So, new resistance can be assumed to be something R dash. So, comparing these two, I can write down V is equal to IR, that is equal to 2I into R dash. So, from this part we come to know that R dash is equal to R by 2. Whenever the current will be whenever the current will be increasing by same value, that is whenever it will become twice than the initial value, then radius will also change and the final radius will become R by 2. So, since initial radius which was rho L by A, so final radius R dash, that will be rho into 2L by A dash. Is that okay? Assuming the final area of cross section is assuming it to be A dash, and we have got the result of R dash is equal to R by 2. R by 2 means it is rho L by 2A, that is equal to rho into 2L by A dash. Are you getting me or not? If new resistance become half of the initial value, R dash is R by 2, okay. So, instead of R dash, I can write down R by 2, and for R by 2 you can write down rho L by 2A. So, rho L gets cancelled out, so it is A dash is equal to 4 times A, correct. This time area of cross section need to, yes, 4A1 is equal to A2, correct. So, are you understanding the argument, how we need to discuss, how we need to talk about the change in area of cross section corresponding to the change in length, so that the same current or a new current information is given to us, right? Fine.